does that. And if you can't, then you have to admit that this line of thinking is unique to quantum eraser.
I'll have a good look for you. I'm sure I've got something saved around already. I'll have a good look. And I'll present it to you.
The truth is that modern scientists, adult scientists, the real scientists, the reason why the scientific method is only a vague guideline is the fact that they all have different needs under different circumstances, and all that they really need to do in order to be doing science is to have hypotheses and then find ways to test those hypotheses, and that takes the form of a lot of different shapes, some of which might comport to what QE says it has to look like, and some of them may not, and they're all still valid. I think there's a great quote, Jim, that you usually bring up, which is, there are as many scientific methods as there are scientists using them.
Right.
If I ask my 15-year-old daughter what the scientific method, she wouldn't have a clue what I'm talking about. Never been taught it.
Okay.
So have we reached agreement that about the natural world? I mean, that seems to be like one of the biggest problems.
I'm about to post the bunch of evidence.
Right, but to the flat earther who's been speaking on this, do you agree that the natural world includes a subset of everything that exists and is tangible?
It's gone off to try and find me a reputable source that agrees with quantum eraser, I think. So he may be gone some time.
Yes, don't hold your breath.
You'll pull up Anthony Riley.
Oh, God, no.
He's actually the first person I think that I've ever got. I've asked this question many times and it always just gets avoided. And I think he's the first person that's actually gone off to do it.
Yeah, he seems pretty legitly like earnest.
Yeah.
Isn't this the guy who was here yesterday called Mark?
I think he was here yesterday, wasn't he? Sounds like that guy.
I think he's had a personality transplant in the last day.
Why, wasn't he doing similar yesterday? I thought he was.
I think he was being more antagonistic yesterday.
Right. I've got no bloody internet. I'm on my phone.
Oh, how have you managed that?
I don't know. Apparently Virgin are working on it.
Oh, dear.
Well, if it is Mark, he sits on betters and loves QE, so...
Isn't he the one who said yesterday he'd heard of Nathan Oakley, but not QE?
Correct.
Oh, yeah, that was it, yeah.
Which is just the biggest...
Seems to have heard of him today.
Yeah. I mean, if you
they all say that, though, don't they? Whenever you say, oh, you're parroting QE, they all say, oh, who's QE? Never heard of him.
Yeah, righto.
I remember when I joined this community, the day I found out about Oakley was the day I found out about QE. You can't just not meet one or the other, not the both.
They're joined at the fucking hip, aren't they?
Yeah.
Well, might as well be.
Should we unserver mute Jen and stuff?
No.
It was almost as if they all came in to ask
No, we
questions,
can unmute him.
like reform their fucking statements.
Okay, I just didn't want to be rude. I'm not going to be over here like everybody else and be like sneaking and unmuting him. Nah. But it would be nice to have him around. Just saying. Thanks, Jim.
You like having somebody who just screams all the time and doesn't let anybody talk? You like that?
And does
not that
bad.
Come on.
Jeez. Really? Oh, God.
He's not
Look,
terrible.
Jen is my friend. We all have passion behind things that we believe in or whatever, and Jen's just very passionate, and I just know Jen very well. And I can get the same way, and so can Jim.
He
You just hear
yell
Jim
at himself when he's in
freaking out on here. We all do it.
The thing is that Jin has the habit of he'll talk, then he'll stop, and then somebody will start talking in his place, and then all of a sudden you start talking again.
Yes.
It's like, what the heck? He won't shut up.
It's precision trolling.
Oh, yeah.
One of my favorite days was still the day he started yelling at himself.
Oh, yes.
Chemo,
I've heard him
Classic.
yell at himself. Yes.
That was brilliant.
Chemo, this tactic is Quantum Eraser's tactic, and it's no good. Of course, you can find some quote that says, for instance, the final arbiter of truth in science is experiment. But now you have to establish that when this person wrote the word experiment, they meant Quantum Eraser's 4-step method and nothing else. And you haven't established that. And that's why I say, just find me a reputable source that rejects astronomy, geology, and paleontology as fields of science. And then we know that they're understanding these words and using all of this stuff in the same way. And you're not just cherry picking bits and pieces out of context and then piecing them together, where one person writes the word experiment and means one thing, and somebody else writes the word experiment and means something else, and then you add the two together and make them mean what Quantum Eraser has. So if there are people who are actually following his line of thinking, there should be reputable sources that reject astronomy as a science. So go ahead and find me one.
I'd just like to pitch in, Jem. I've sent in through DMs some relevant, some relevant slides to this current discussion. How QE will argue that it has to be experimental when it comes to the scientific method, but I've sent through like you could have like descriptive, modeling, or theoretical when it comes to mathematical. So, and these slides they also provide some examples, obviously. Relating to those different methods as well. So, I mean, I was going to put them on the chat here, but the chat tends to speed through a bit too quickly to put them all in at once.
Right, got you.
Hmm.
Cool, thank you.
Yeah, I remember they this was covered in a particular lecture that I was in early this year, so.
Interesting. I've done a couple of videos that sort of cover this to some extent, where I've tangled with QE. Again, Chemo, you haven't got him covered. This isn't what I asked for.
That's why this is physics, Kiro.
Yeah.
Even if that was 100% what you were looking for, it doesn't cover any of the other sciences. It begs the question why they would specify.
Here's the rest of the. Here's the rest of the definition that he omitted.
Has QE ever addressed why he's using statistical hypothesis when he has got this definitive causal relationship?
There's the rest of the definition Chemo didn't post. This time I posted it.
Sanjay, what is it?
908.
70% discovery test or hypothesis or demonstrated no impact. That's different than what he was posting, right?
I think the second definition is a little bit less specific.
I think both are fine. I think the only problem is why is QE using a statistical hypothesis? Because he doesn't.
I know he does that, right? Yeah.
He's saying it can only be cause and effect. So
I know.
Why would he use a statistical one?
I know.
I think it's because in the null hypothesis, I mean, that should just be a negation of the alternative, right? And I think they must, I'm sure I've seen it somewhere where it's written as a default position or something. So they like this, don't they? Or certainly percent does, where he says, well, by default, the Earth is flat, which is another problem they have.
I mean, QE's full of these kinds of contradictions. Like his obsession with begging the question, he never stops to realize that every time he gives an example, if he was right about what's begging the question, every time he gives an example of a hypothesis and experiment, he's doing the exact same thing. I don't know why he never notices this. Of course, he's wrong about what begging the question is. It's fine what he's doing when he gives those examples. Those examples are right. But it's weird that he doesn't notice he's doing the same thing.
Yeah, you have to approach every question with a totally blank mind on the subject. You can't have any preconceived ideas about it.
I don't advise that today. I tried that with the stove, and just because other people told me it would burn my hand, but it does. Now I have an owie.
Well, that's just your confirmation
Physics,
bias.
that's true. In physics, it's experimentation is king in physics, but there's lots of other sciences.
Oh, Chemo, you call me a fantasy boy. And you think the greatest minds in history all agree with you dumbass flat earthers? How fucking deluded can you get?
But he's just playing the same game as
I know.
QE. Sorry, go ahead, Barry's.
Oh, that's right. I was just going to just quickly announce that if anyone did want those slides in the future, I've just placed them in Gary's dump or Autismo's dump so they can go back and use it whenever they feel like. Just because this chat, will fly by and all the rest of it.
Nobody goes there.
I do.
All right, then call it Scott's dump.
No, it's Gary's. I go to Gary's because it's Gary's.
Well, you need to respect Gary's boundaries and rights.
He's invited me.
Jem,
He didn't
I
mean
think
it under
I
duress.
found it. I think I found where QE's got his 4-step thing from. You want to send it to you?
You go ahead. I've got videos on where he got his 4-step thing from, though. But
I'll just send it. Just one of them that I found already. I'm just gonna put it into the chat. Should be in there now. Well, I can share my screen.
Yeah, we know about
this.
This one. Yeah.
You know what's funny about that one? You know what that is? That is a handout.
My screen.
That is a handout of a lab sheet for a chemistry class at Rochester University.
Yeah.
And so in the context of that class, it makes sense because the only things they're going to be doing in a chemistry class in a first year freshman year is going to be chemistry experiments. That's exactly what they're going to do. So they don't bother to give a general version of it. They're giving the version that's relevant for the class.
Yeah, what I'm trying to say is this is where it comes from. So it is a real thing. This is it.
Well, yes,
I'm not denying that, dude.
Okay,
what I'm denying is that this defines all of science, and that isn't shown in this thing. So that's why I say you need to find a reputable source that follows this entire line of thinking.
This is one, though. Would you agree? This is one.
No, this is not one at all. No, this is not one in any way whatsoever. I'll tell you why we know this, because this comes from the Department of Physics and Astronomy at this university. That's where this thing is from. And you're telling me these people don't accept astronomy as a science. The guy who wrote this, Wolf, the guy who wrote this, is an astronomer with dozens of scientific papers attributed to him that relate to astronomy. Black holes, I think, is his thing.
Does that make sense, Rob?
Well, I did find this one for you, right? This is one.
No, but do you understand why he's saying it doesn't count? Because
I hear that. I hear that, but this is one already.
Because why are you saying that when it's obviously doesn't count?
He hasn't made up his own one. I just want to highlight that.
Yeah, but that's not what you have to do. That's not what you have to do.
Yeah, my point was, like I said, you can go out on the internet and find QE's scientific method. I'm not denying that happens. What I am denying is that scientific method, and that alone defines all of science, because that's what QE says it does. If it's not that, it's not science. It's pseudoscience. And I don't think there's any reputable source that follows that line of thinking. I know there isn't. And this is not a reputable source that follows that line of thinking. Else they would not have an astronomy department at their university.
I'll keep looking, but this is one. I'm going to take this one.
Well, I don't understand. Why do you call this one when this is not at all what it's saying?
Well, what I'm trying to say is that this is what QE uses. So
Yes,
he hasn't
we know.
made up one. He hasn't made up one on
but does
his
this
own.
source-
No one said he made it up, though. They understand that no one ever said that. We're saying it's not.
Okay.
You're never going to find it saying that this is the definition of science. That's what you have to find.
Well, this is just one university who uses the same as what he uses.
It's a class.
You agree?
It's one class. It's one
Would you
class.
agree?
Yeah. It's one class.
Perfect.
Yes.
Perfect.
Yeah.
Okay.
That's no big deal. There's a lot of classes that use it. There's a lot of times you'll use that method. It's a valid method. Wow, that's the key. That I don't know if you understand. It's not that he's saying something wrong. He's just restricting it incorrectly.
Okay. I'll try and dig a bit more.
Just look for something general.
Jem asked you specifically, show where any reputable source says that astronomy and geology and
University.
Paleontology.
No, it's not about the source, guys. It's about whether it's saying it's the definition of science. This is a valid way to do chemistry, absolutely. In that class, that's exactly what they did, and it works. But that doesn't mean that astronomy isn't science.
I didn't say that.
I know,
Yeah,
but that's what
QE
QE
does
says.
say that.
That's what
Yeah,
the
I know,
whole point is.
all I'm just saying, this is what he uses, and this is what they use. So
Yes, we know.
high
There's lots of
standard.
methods, though. But our
This is
point
a
is
high
there's more than one. Our point is there's more than one method, right? And that different science departments or different scientists use different methods.
when you're working with
And-
adults, this is probably the one that you
Let me
use.
finish. Let me finish. There's different methods, and different scientists will use different methods, and no one method is the correct method, right? If they're all valid in different ways. And so when he says, "I have this one here," I'm going to read it to you, and he reads it. And he says, "Now anything that isn't this isn't science." You know something's fucked up when it comes from the Department of Astronomy, and by his version of reasoning, it would exclude astronomy from science.
Yeah. Beach, can I say something real quick, honey, and ask you a question after reading that? Honestly,
Sure.
I'm confused here, but on a level of understanding from me, I need from you guys too. Like, look, if that's correct, one, I'd like to know when was that published, and second,
Was what published?
if that is correct, wouldn't then everything be considered natural, even including the sky? That you'd have to apply the scientific method that's used for natural science then almost to everything then?
When the word natural science or natural philosophy is what it was originally called,
Right.
when that word came about, what they were trying to do, this was in early 1700s, okay? What they were trying to do was separate out studying of the world through the lens of spirituality, through the lens of God and angels. So there was a time in which a lot of the quote-unquote scientific reasoning of the time was built around beliefs that people had from the Bible, a belief they had from church. There were arguments like, if you were sick, it's because demons have invaded your body, that kind of stuff, right? So what they were doing was they're saying, we have a new idea. Our idea is that we're only going to deal with things that you can touch, you can see, only things you can measure. We're going to call this natural, okay? This is the natural world as opposed to the supernatural. That's why they carved it out. And so, yes, it does include the sky, anything in the world that you can analyze and touch and read or measure, it includes, yes.
Okay, and I think this is why it's becoming an issue, because if that's the case, right, everything's natural, then and then we're going to have to apply one scientific method that people are arguing over because it's all natural then, including the sky. You guys can't apply that natural, that scientific method.
You don't do that. You don't ever want to do that. That's another mistake, right? It's not just one scientific method. There's a lot of different ways to do science. And so, for example, astronomy often doesn't do experimentation. What they do is observation. They do scientific observation. So they'll figure out an hypothesis, and then they'll figure out a way to look at the universe for some period of time in order to get a way to test whether the hypothesis was true. And if they do that correctly, it's just as valid as an experiment is.
And also, not everything is natural. Like a book isn't natural.
What is it?
Like not everything is natural though. Like books aren't
Why?
natural. Cars aren't
Books
natural.
are natural. Books are not. In this meeting, it says the meaning. Look, I'll post it for you too. You need to read this thing first. Let's catch up with what we're talking about.
And
I'm posting right now.
I appreciate you each posting that. I will look into that more. I appreciate it. I'm being very sincere here. And I will actually take that up with Quantum because I'm not I want to know
we
both sides.
Yeah, we've shown him this stuff
what I
before. He
want
just
to see.
ignores it, in my experience. But maybe he'll listen to you.
You know what I mean? So I'll look into that, Beach. Thank you for doing that for me, though. I really appreciate
You're
that.
welcome.
So as to the books are natural question, how are they not natural?
They are unnatural. They're unnatural objects.
So they are not made of materials that exist in the universe?
Well, they're made of natural materials, but a book itself is not a natural object.
Yeah, I'm inclined to agree with him. It's made of natural materials, but it's not a natural thing. It's not actually, it doesn't naturally grow in nature.
The word, look, in the context of science, the word natural does not mean man-made versus not man-made.
Yeah,
in the context of science, natural means physical versus supernatural.
Yeah,
so when we say,
but there's supernatural and unnatural. Those are
well, what's the difference between unnatural and supernatural?
As part of nature, everything we do is natural. So therefore, a book is a natural thing.
Well, Alien, what's unnatural versus supernatural?
Well, you can't even say that a human being is a natural thing.
So what's unnatural versus supernatural?
So we're not natural now, right?
It's possible. Well, you can't prove that we're natural.
Okay, but what's supernatural versus unnatural?
Well, supernatural is a natural thing that defies the laws of physics. Like I can run, but I can't run 100 miles an hour.
Okay.
So if I could run 100 miles an hour, that would be a supernatural thing. I'm doing a natural
so what's
thing
unnatural?
that, unnatural is something that nature is not capable of creating. Nature is
so both of those things are not. Okay.
Mars. If you found a book on Mars, you wouldn't say that Mars made the book, right?
Okay. So natural kids. So that version, though, there's two definitions of natural. It's one definition is the opposite of unnatural. One definition is the opposite of supernatural. What we're saying is that in science, we're using a definition that is both, right? Natural in science is going to mean anything that is. It's going to be just the one. It's going to be anything that is not supernatural, but it will include things that you would call unnatural, because of course you can do science on a man-made object. It would never occur naturally, but it's still natural science because it's not supernatural science.
Well, yeah. All components of reality are. You would say that they're natural.
That's right.
Well, actually, you can't even say that. You can say that you can't say that their characteristics are natural, though, because
Well, I think the key here is that if you look up the word natural, like every other word in the English language, it's going to have about 4 or 5 different sense meanings, all of which are slightly different than each other, right? Depending on your context, you can mean different things.
True.
And when you use it in science, what we're meaning is physical.
Okay, I get it.
Do you agree with it?
Well, yeah. I mean, these are all systems. These are all systems of cooperating parts, and you would say that those parts are all natural, even though their characteristics can't be proven to be natural. But yeah, sure.
So can I do science?
Just like a human
being. Can I do science in a book? Can I do science on a book?
Can you do science on a book?
Yes.
I mean, well, if you're using the what definition?
What's the cause of the book?
No, that's not the question. You got to find out what the question is before you say what caused the books. People did. What is the temperature that they burn at? That's another question. Is there a problem with
when is the ink made out of? Yeah, what is the ink made out of that's written in there? Yeah,
so you
how
can
do
do
they
any
make
number of sciences on book.
all that stuff.
Yeah, man. What
you hit someone with one before? It's great.
Great book, you know.
Well, you can collect science about books, sure.
Yeah,
no,
exactly.
I can do
right.
We're just growing fungus.
Yeah, same thing.
So that definition that quantum uses has no use when he says that you can't do it on man-made objects.
Well, what quantum relation tells you is that not only can you not do science on man-made objects, he says you can't use man-made tools. And if you really take the logical extreme of what he's saying, there's almost nothing you can do because you can't use a Bunsen burner, you can't use glassware. I mean, it's just absurd. I don't know how people don't catch him on this stuff.
Well, the statement of doing science is kind of weird, though, because
it is a weird statement. You're right.
You can't really do science. You collect science. You create.
Yeah,
science.
well, you can apply the scientific method. I think is what it's a shorthand for saying.
Okay. I get it.
Yeah.
Sorry, I don't mean to be.
Are you alien robot? Are you a flat earther or?
I'm not anymore.
Yeah. Okay, I can tell. I think at first you thought you were, but I can tell you're not actually, and there's a little confusion.
According to QE, you can't use the scientific method because it's man-made.
Exactly, right? Good point. It's true. So much to tell him that. But of course he doesn't listen.
Surely the term man-made means the science has been done on it.
No, it does not mean that.
Wow, that means that all of aviation after the Wright brothers.
Man-made is technology, right? That's engineering.
Technology is man-made. Yeah. Oh, okay. That's not really that's not the distinction, though.
Well, yeah, it's just
Cake is man-made, but you still use natural ingredients to do it.
Well, it's just like the
Wouldn't
DNA
the science of making the book already have been done, like binding the pages, doing the spine? All that science should have been done when they created it.
I mean, I think you're stretching the definition of science there a bit.
Yeah.
Constructing something isn't necessarily science.
All you're doing is back engineering. All you would be doing is back engineering what's already been scienced.
Well, no, because you could ask yourself a scientific question about a man-made object. Like, for example, if I have a shoe, which is the example I used before, if I'm trying to figure out what can I do to this shoe in order to make this shoe more effective, I could use scientific experimentation to come up with a scientific answer about what types of rubber are the best rubber to use to make this shoe the most, springiest or whatever. Right? That's something one could do, and that would be science.
Is that creating a shoe or science in a made shoe?
That's deploying science on an existing shoe in order to figure out how it might be changed.
Well, then surely that science has already been done because it's in your hand.
I know, but that doesn't necessarily mean that somebody's figured out this answer to this question.
Also,
new shoes come out every year based on the old science and additional science.
Yes, well, they've extended the science that they've already done, obviously, or adapted it to improve their product. But that doesn't mean you can take their product and then science their product.
Of course you can.
You could back engineer their product.
It's a different thing.
You can't science it.
Of course you can.
Yes, you can. Sure, you can. You can take something, improve upon it. If you take something and improve upon it, Brian, have you not just done science on it? Like you've improved it. You've done something better to it. So you've taken something existing and added to it. That's doing science on it. It's improving it, making it better.
You don't need to make it better. You can find who wore it.
You could do testing and experimentation to
figure
out the character.
So you want to create a shoe similar to the one you've got?
No, you don't have to want to create anything. All you have to do is want to answer a question. Scientific method basically goes.
Just ask the fuckers who made it.
Well, they don't know the answer to the question. Mabbit, listen just to what I'm saying. Try to understand this. Just open your mind up a little bit. So if you have a shoe, let's say, okay? And let's say your shoe is wearing out too fast and you don't know why. And you think to yourself, you know what? I've noticed lately that there's a certain kind of bug that I've been stepping on a bunch. I have this hypothesis that this bug is acidic and this bug is eating away at my shoe. So now I can run an experiment with, I can do an experiment, design an experiment, I can run the experiment to discover the answer. That's prototypical scientific method science that I'm applying to a shoe in order to get an answer that it will not be able to be told to me by the people that made the shoe, because they didn't worry about this. They probably never seen this bug before in their lives. Does that make sense?
Or something more realistic, like this shoe slips on this slippery surface for some reason.
Sure.
But
There you go.
the tread in the bottom of the shoe, there is no tread in the bottom of the shoe, which is why you're slipping around. So they just cut grooves into the bottom of the shoe to create a liquid or whatever it is to go out.
Sure.
Like a car tire. If you cut tread into the bottom of the shoe, it allows the fluid to squish out from underneath your bottom of your shoe quicker, which allows you to be able to grip, which allows that shoe to be able to grip the ground better. It doesn't slip on slippery surfaces as much. And so you could do kind of experimentation to see like how much grooves it takes to so much. It doesn't necessarily have to be anything that really changes the chemical composition of it, but it could just change the configuration.
Do you have to revulcanize your tires anymore, anyone?
Yeah.
You still have to revulcanize tires. Well, you might.
Yeah, truck tires you do.
So I'm talking about people that drive around. Does anyone still revulcanize their tires when they're driving around nowadays, or they just replace them?
They replaced.
No, you can still get retreads, but I don't know if they
I don't think
still
people
sell
do
them.
that anymore, really.
So that might be something we've improved upon. Revulcanizing tires. You know, we make better ones so they last longer.
That would be cool.
I think you're reinventing the wheel myself.
They have many times.
So what?
Yeah, with
So
a
what if they
propeller.
have?
With a propeller.
Using
That
science.
isn't science, is it? If you
Yes.
just
Yeah.
reinvent something that's already invented, you're just reinventing the wheel.
So the cars we've got today, are they the same sort that Henry Ford made originally? Yes or no?
No, they've improved, obviously.
There you go. That's an example of science. And Brian, thanks.
Yeah, but
Thank you.
Yeah, but Brian, how did they improve it? How did they work out what was a better tire than what they had?
Well, they've probably done different blends of rubber and done different tests on them. Loading.
That's a scientific method of an experiment to work out which tire's the best wearing tire, the best one holds heat. You know those tires they put on the machine, and they've got a big metal rotating drum, and they turn the tire at certain speeds and work out how much the tire can flex and heat up in its bands in the.
Yeah. Pressure loading, like.
Yeah.
I think we're arguing over fuck all myself.
Yeah, probably, Brian.
We can ask a question like, what happens if we use carbon nanofibers in the tires?
It's called fucking product research, Brian. Look into it.
I think a question might be, why is it useful to be making this distinction? Why do we need to say, aha, no, that's not science, that's engineering? How does that ever help us in any way?
It's for the advancement of knowledge, right?
No,
I've all on Jet 1020.
But how does it help us to be making this distinction between the two?
I don't think it does.
I don't think it does.
I don't think it does.
The point is to break down conversation so you can deny pieces of science.
I think it's just another little quantum eraser trick that allows him to sort of, deny something out of hand by just saying, "Oh, well, that's not natural."
Like the cat is both alive. Like the cat is both alive and dead, right, at the same time.
Jeb, is there a scientific method laid down or not?
It's because we haven't collapsed the wave function yet, right?
Because when I Googled the scientific method, it repeated everything that QE says.
Right, but again, my point is, of course you can find that version of the scientific method online. What you cannot find is people who use that method and that method alone to define all of science. I don't know how, it must be so boring for people to keep hearing me say this over and over. Right, and Chemo is still quoting little bits and little citations from people, which he then from different sources, and he adds them together to make something that those people were not saying. And that's why I keep saying, just find me one reputable source that says astronomy is not a science.
Again, if you look at the definition of pseudoscience, the definition of
an Anthony Riley trick. Now we'll define science by looking at the definition of pseudoscience.
Well, that's how we
won't look at the definition of science. We'll look at pseudoscience.
So how about cosmology?
That's how we get our definitions from the Oxford English Dictionary. And if pseudoscience says it's a collection of beliefs mistakenly used as the scientific method, then it's not science. Right?
Again, just find me one reputable source that agrees with QE on this. It shouldn't be that difficult. If this is all there is, if this is what the scientific method is, you should be able to find a university or something somewhere that says it's not that astronomy is not a science.
Well, look at Google. What Google says.
What am I looking at now?
Astrology has been rejected by the scientific community.
Astrology.
Is cosmology a science?
Astrology,
Yes.
not astronomy.
Sorry,
Astrology
astrology
is not a
Astrology is
science.
not a science. Yeah, that's not a science. That's a
Astronomy is a science, and that's what he's asking for. Astronomy.
No matter what they
What do you
what they
define?
say, if
What
they
do you
say it's
define as
science,
astronomy?
they
How do
say-
we define astronomy?
The
You
study
won't
of the
need to.
stars.
You won't need to. All you need to do is find some university website or something like that says astronomy is not a science because you cannot do experiments in astronomy that that comport with this 4-step scientific method. That's all you need to find. Apparently, every educational establishment agrees with QE on this, according to you guys. So it shouldn't be that difficult, should it?
No, according to QE, the queer fuckwit.
Hold on then.
But
Hold
how
on.
are you
Hold
experimenting
on.
on
Let
the
me put my
side,
best man
man?
on it.
How?
Chemo. Do a quick search on that then.
like I said, we're going with the definition of what pseudoscience is, what science is.
Why? Why are you defining science by looking at the definition of a different word?
I want to know what pseudoscience. I want to know what not science is. What is pseudoscience?
Well, why don't we figure that out by finding out what science is? Let's look up the definition of science from the same source as you got your definition of pseudoscience.
Can I ask a question? Why are we arguing definitions? The more I think about it, these show me proof, supposedly, you know what I mean, that natural science is now things that I was told differently of, right? So, okay, if natural science is going to include all these other things, fine, wonderful. But if you don't want to use the scientific method to prove things in science, that's confusing to me. Because as someone who would believe in the globe, I'd want proof of things. And that's what the scientific method that QE breaks down is supposed to be, proving things. If you want to just experiment on something with no actual proof and you just have an answer with just maybe a question mark at the end, fine. But science should prove things.
Okay,
what other types of science are there? Wait. What other types of science are there besides natural science?
Hang on, Stacey. The fact that you just mentioned the words QE makes me want to say that what the fuck are you on?
Great. Well done for interrupting the conversation to say that, Jezza. That important and insightful remark. Brilliant.
Thank you for that
input. I'm questioning QE, so I don't know what the hell you're talking about, Jazza, right now.
Good. I'm sorry, Stacey. Good, you're questioning him because you should be. That's
Okay,
what I'm
Jazza,
saying.
please, just stay out for a second.
Stacey, I think it's important to remember that what they teach in high schools, I don't know about elsewhere besides Australia, right? So I can't speak on other countries' behalfs. But what they teach in Australia, at least for high schools, they teach a scientific method, right? And it's the one, like, I go to, let's say, other flat earth hangouts, right? And they'll have like these certain like steps 1 to, I don't know, 4, for example, let's say, right? And they'll say that's the scientific method, right? But the reason why they make it like that is so they simplify it down for children in school, because the reality is it's not exactly a linear process, right? It's a more like the science. Yeah, it's more circular, right? Just hold on.
Steps
let him finish, Chin.
Right.
Go ahead.
So it's more circular in nature, and I'll put down an image in a second and tag you in it. But they don't go on about all these other different methods, you know. Some of them which I posted before and flashes edited into a GIF, and that's because it would be confusing for children otherwise. They make it so it's easy to understand, and this is all they need in high school at that time. Obviously, once you go up, the next step would be like university, right? Once you go to university, that's when they expose like what it really is and go, well, look, it's not just one way that we do things, if that makes sense.
And what do we teach? What do we teach children when they're at school? What's the scientific method?
We don't teach them the scientific method at school. At least in the UK, we don't.
Working through science. So what do we teach them? What are the steps?
I was referring to Australia. I don't know what happens in other countries.
Again, it doesn't matter if you can find the steps. For the 10th time, it does not matter. No one is denying the steps. What is being denied is that the 6, 4, 7, whatever number of steps it is, define all of science. For everything that isn't that is not science, is in fact pseudoscience. That is what is being denied.
But how can you
Please,
demonstrate that?
Try and understand this. Try and understand it, please.
But what evidence do you have?
It's not difficult. Again, I am not denying. You will find reputable sources that quote that scientific method. I am not denying that.
Yeah, but what evidence do you have, or where are we getting the knowledge from that these other areas are science? I mean,
Timo,
just
Barry's
because
talking.
you label something science, does it
It's
mean?
so frustrating. I can't believe.
I'll tell you the answer to that.
Barry's, go ahead.
Thank you, guys.
Yeah, so
I was just gonna chuck in into the chat just a more like this is what they might present in high school, right? So this is a really basic one. No one's denying that, but in reality, I'll just go a bit earlier. I'll show you it's a bit more circular, right? I'll just scroll up. Just give me a second. Here we go. It's a bit more like this, okay? And there's a GIF, like I said earlier, that gives you some examples, which I'll place here. So there's not just one way that we can go out and gather data to test a hypothesis, right? There's different ways that we can go about that. That's all I'd like to say. Thanks.
Yeah,
so I'll just paste it down and leave it there.
You're right.
Thank you very much.
And a key consideration, a key difference between what QE says and reality is that in his mind, there's only one way to test a hypothesis. His mind, the only way to do that is through a controlled experiment. And anything that doesn't use a controlled experiment to test a hypothesis, he says, does not count as science. And that would include things like astronomy, geology, paleontology. And the fact, though, that if you go and you look at various definitions of scientific method, which you can find all over the place, all different places have slightly different phrasings for different things, you're going to find many of them are going to say things like, you can test your hypothesis using either an experiment or a scientific observation, which would be a direct contradiction to what QE is saying. And the fact that these exist, and these exist in abundant schema, I think is where the evidence that you're asking for is. Why would the world where we find versions of the scientific method include observation if that wasn't a valid way to do science?
Yeah, an observation, a simple scientific observation does not always conform to the scientific method, though.
Of course it doesn't. That's not what I said, though.
I'm sorry?
Not even science.
Of course it doesn't, but that's not what I said. It's a step inside. Sometimes you can use a scientific observation to test a hypothesis.
What?
Wait.
Yeah.
So, but it wouldn't be scientific. It wouldn't be
Why not?
conform to the scientific method.
Of course it would. I'm telling you, if you go, I'll say it again. If you go and you read versions of the scientific method out there, you're going to find lots of them will say in the part where they're talking about testing the hypothesis, they'll say something like, you then test your hypothesis using an experiment or observation. You can test your hypothesis via scientific experimentation or scientific observation.
An observation is not a test, though.
Well, hold on
You
a second.
absolutely can test it. Hold on, I'm in the middle of answering this question. Using observation, I'll give you some examples. When we were testing out the perturbations in the orbit of Uranus, we used scientific observations to test the hypothesis. The hypothesis was there was a previously heretofore unknown mass that was causing these perturbations to occur. Well, how are you going to test that the hypothesis somebody had? Well, you're going to get your telescope, you're going to point it at where you calculate you think this mass should be, and you're going to observe whether it's there or not. Then that way they confirmed their hypothesis to be true, and we got figured out that Neptune was a planet.
But that's an observation. That's an inference. That's not really.
That's a scientific. Look, when I observe whether a mass is somewhere or not, that's a scientific
he wants to
observation.
respond to what you've just said.
I heard what I said. When I observe that a mass is somewhere, right? That's a scientific observation. Am I right or wrong about that?
Right. Yes.
So then I can use that to test the hypothesis. Am I right or wrong about that?
What hypothesis, though?
That there's a mass at this spot in the universe which is causing the perturbations of the Uranus orbit. Really, the hypothesis is there's a mass at that spot.
You're presupposing
you're talking about Pluto, then. You're talking about Pluto and
Neptune.
how it. The way they found out that Pluto existed was by the
not Pluto. Neptune and Uranus.
You can't even hear this guy finish a sentence.
It's okay. It would help if you just hushed. So Neptune and Uranus are the two planets in contention. But yes, this is how they discovered the existence of Neptune.
And so the hypothesis is there's a planet out there that we think there's another planet out there, and we're testing to see if there is actually another planet out there.
That's right. And in fact, in astronomy, almost all of the hypotheses are tested with observations because you can't really. It's hard to run experiments on the scale of the universe, right? So a lot of times they have hypotheses, and they'll test these hypotheses by coming up with a way to view the universe, observe the universe in very particular ways in order to get to find out whether the hypothesis was true.
All right. Well, let's bring it back down to Earth then. Say if I'm looking at two fossils, right? I want to see if these two fossils are if they share the same ancestor. They share a common ancestor, right? Would you say that it's scientific for me to examine those two fossils and determine that because of their similarities that they do in fact share a common ancestor?
Well, I don't know if I don't know if that's true or not. I don't know if that's a valid method of doing it. I don't know if about paleontology, but I think the issue here is that there are going to be times in which you have a hypothesis that's only going to be testable by experimentation. There are going to be times in which you have a hypothesis that can be testable by observation, and probably times in which there's both. And all three of those situations I just described, all three of those are encompassed in and part of and are reasonable forms of science.
Well, I'm just bringing that up because they do, in fact, that is in fact how they determine
He makes it up as he goes along.
As far as I'm concerned, that's not scientific at all.
That's right.
For a human being to look at two fossils and just decide that they
match,
that they have the similar characteristics, therefore they must have a common ancestor. Or
well, but that's a problem. So you actually have the problem with inference, then, right? You have the problem with what you think they're doing isn't actually correctly doing it. It'd be like if I said I got this scientific experiment and I described to you something that just wasn't an experiment. You'd be like, well, experimentation is fine, but what you were going to do there is not going to work. You're saying that what they're calling that observation they're calling, that's not a good observation. That's an observation. I might say I'm going to tell you if there are two ancestors by observing where they were located and whether they're pointing north or south or east or west, and you'd say, well, that's an observation, but it's not really going to. I don't think it's a very good one. Yeah, that's a slightly different though. It's not your plate is not with observation. It's inherently your plate is with that particular observation.
Right. Well, I mean, we could take it back to the universe. How about gravity waves? Do you think that gravity waves are scientifically established?
Yeah, I think so. I'm not really an expert in this area, but I think so. Yeah.
Even though there's science that proves that gravity waves cannot be detected from inside of an existing gravity wave or gravity field, like
I guess I don't think there is science that proves that. Otherwise, I don't think we would have detected gravity waves.
Right. Well, do you so you think that we have detected gravity waves?
I mean, I think so. Again, I'm no expert in this, but that's what was reported by Popular Science, right?
Well, the thing is, we just can't repeat these. A scientific model is something that could be tested, repeated, and established.
Yeah, before you say anything wrong, you're wrong because it is repeated at least twice.
How can you?
Because there are two observatories.
So how can we repeat?
Because there are two observatories that observe the same wave.
I've not even finished my.
You don't need to.
You can't even finish.
He does need to finish. Sorry, but he does. Go ahead.
How can we recreate the collision of two black holes a billion light years away? How can we?
He did just answer that though. His answer still applies.
No, we can't recreate that though.
But there were two observatories, so two independent people replicated the experiment.
How? How can you replicate the experiment of two black holes merging with each other a billion?
Because two independent people registered the waves.
No.
It's as if one experiment was one place and another experiment was the other place. You have two of them now.
Yeah, like if a car crash happens and you have more than one witness, you can confidently that the car crash happened.
But there's 4 antennas on this planet, and only 2 of them detected these gravity waves. And
so that's 2, is what he's saying. He said there's 2.
But there should have been all 4.
Well, I'm not sure that's true. Look, here's the problem with this is that I don't know if we have anyone here who's a physicist, but typically we do. But I cannot prove to you because I don't know enough about it. Maybe you can tell us if you know a lot about it. Why it is that we should disbelieve these results that we've been told. But the truth is. Clearly, they are not so clear-cut, though, that people are not reporting it this way, right? It's being reported in mainstream science as if this is something that we can, that is reasonably true so far. Now,
you're going to call it a conspiracy theory, though, but there is reasons. Like,
how sensitive would the detectors?
Let him finish, Brian. Let him finish. Go ahead.
The two.
I can hardly hear him, mate.
Well, I don't care. That doesn't mean you just get to talk over him, does it?
No, I mean, I couldn't hear him. It's too quiet.
All right.
Is my volume?
Get him to project
Your
his
volume is
voice.
very low.
A bit louder, dude, if you can.
Yeah, project your
I'll,
voice.
let me see what I can do. Sorry.
All right, don't
That's
worry
better.
too much.
You're pretty good. You're pretty level on mine. I
Yeah,
usually
it's all right. Don't worry too
Yeah,
much.
but you're in Australia. You're probably.
Brian, just shut up.
All right. Well, there's two LIGO antennas in America, right? Then there's one in Germany, and then there's one in Italy, right? That's the 4 LIGO antennas that are on the face of this planet. The 2 in America, they were 3 weeks from losing funding and being shut down forever. Whenever they made this detection, the 2 overseas, they did not make the detection until after they had spoken, which they're never supposed to talk to each other at all. But they did. They spoke to each other, and then after that, the ones overseas suddenly they had some kind of detection. But if you look at the lasers, they're measuring the difference in the synchronicity of of the wavelengths of 2 different lasers. That's the value of less than the width of a proton. So if these 2 lasers are out of synchronicity by the length of the width of a proton, I mean, we're talking freaking.
Yeah, lovely incredulity. How do you know all this detail about this conversation that they have between these 2 places? How do you know about that?
I mean, there's records of it. There's records of them having, but anyway, like.
Hold on a minute. You say they weren't meant to talk to each other, but they recorded conversations between each other, and they've made these conversations public to you. Is what you're saying?
No. They didn't make the details of the conversation public, but the fact that they talked to each other is known, but nobody knows what they said.
How is that known?
I mean, they have records. They even asked the people if they talked to them. They said yes.
Yeah,
so,
but
I mean,
you know, have records. I mean,
I mean,
what records?
Of course, there's full records.
There are observatories and radio telescopes and what have you around the planet. We don't normally have access to the conversations that they have with other similar establishments, do we?
But if you ask them, have you talked to the people in this LIGO observatory, and they said yes, then that's all you need, really. So,
well, is it though? Is it? Because that sounds like a sort of a relying on a half truth.
That's what that's why I said.
You talked to them, yes, but you haven't bothered to find out what they said.
Yeah, it doesn't matter what they said. The fact is,
I think it does. It absolutely does.
No,
it does.
They're never gonna tell you what they talked about. They're just not.
Well,
going.
according to you, they have. Or they don't need to. You can just make it up. As long as you know they've had a conversation, you can assume it was a nefarious attempt to detect gravity waves when they hadn't really done that.
They're never supposed to talk to each other, and they did.
I mean, this is why I think this is why in advance you told us we were going to call it a conspiracy theory.
I know.
Well,
I know that. That's why I said that. What I was getting at
is about a conspiracy, aren't you? You have no evidence of this conspiracy.
Is the sensitivity of this equipment. If there's a butterfly in the same room with this laser, it will cause the same effect as a gravity wave.
Okay. And what does that mean to you?
If somebody a mile away claps their hands, it will cause the same thing. It'll cause the same effect as this gravity wave.
But what does that mean to you? I mean, presumably they have methods. They have methods with which to make sure that this stuff is calibrated correctly.
How?
I don't know, but presumably they do, right? Are you saying that the whole thing's a lie?
They need to recreate the collision of a black hole of 2 black holes.
What I'm saying is that we have 2 independent places to see it. 2 independent places see it, right? And now, assuming it's not a conspiracy, right? 2 independent places see it, then we know that the chances of them getting the exact same detection at the exact same time based on some sort of contribution is unlikely, right? Because they're probably registering the right things.
Unless they talk to each other.
Well, except for you're saying it was the first 2 got it, and then they talked to the other 2, right?
Well, the 2 in America, they may
have been inclusion a priority, yeah. Well, so I guess here's my question. I'm kind of curious, and I don't doubt you. I'm actually just curious. Can you point? I was just Googling. I don't find anything. Would you point me towards something that tells me the story of how they're not supposed to talk, but they did, and all that?
Sure. Yeah, let me get that.
Jim, I've got a question.
Go on.
But all I'm saying is like.
Are you saying that clapping your hands creates gravity?
Oh my god.
No.
You just didn't pay attention at all.
It creates an atmospheric interference that these. It creates an atmospheric interference that these antennas can actually detect.
Right. So
They're
they
not
are
antennas, you know.
That might have been slightly. That might have been. I know that might have been slightly clapping your hands a mile away. That might have been slightly exaggerated, but a car starting in the parking lot. Wait, a car's starting in the parking lot of that building would affect the antenna.
Okay.
So they are very, 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 very sensitive to gravitational waves, then, yeah?
I mean, they're sensitive to everything. They're sensitive to everything.
Have they never considered the moon passing twice a day that lifts the water up 20 to 30 miles?
Exactly. And they didn't even like. That's what makes me think that it's all horseshit because we're in.
What I envisage is when they see the moon, they all sit on the equipment because it would go off the fucking scale.
It's easy to calibrate out anomaly or not anomaly.
How can you calibrate out a peak?
It's like you guys are incredulous that you can't have a room full of people and have a guy with good experience with audio equipment single out a single channel for voices. It's like you guys are just so incredulous that this can possibly happen.
What about the sun's gravity? I mean, all of
that stuff is going to be accounted for. Obviously, this is why it's an expensive and hard to make product.
Oh, you can't detect a gravity wave from inside of an existing gravity field. It's impossible.
Clearly, people think you can.
Why do you think that they're planning to build a LIGO antenna in space?
Well, that probably makes it easier. I believe absolutely.
Because
gravity in space. No. You've got the sun's gravity.
Shit! What is this guy yelling at? What is this guy yelling for?
It's just the way it is.
Anyway, they're trying to get away from fucking shit. Okay, never mind.
Nabbit, enough. Okay, enough. Go ahead. Just relax and don't worry about it. It's just the way it is.
I'm relaxed.
Okay, Nabbit, we need you to be quiet.
I'm going to mute him.
He's going to need you to be quiet.
Well, shut the fuck up!
Go ahead.
It's just a conspiracy theory. It's just a conspiracy theory. I'd like to drop the whole thing now, actually.
All right. Well, let me just say one response, Alien, and that is that it might be. You never know. Like, I mean, look, science sometimes fucks up, and we have had conspiracies in the past, and we know like cold fusion can come, and everyone can be cheering and celebrating, and then guess what? It just turns out that those guys maybe have been a little bit dodgy. So that may turn out to be the case. You never know, right? And so I'm not saying that you're wrong, but certainly it can't be as obviously clear cut as the way you're saying, because if it was, and tell me if I'm missing something, this conspiracy is not so all powerful that there wouldn't be people talking about how this doesn't make sense, right?
Well, there's like literally billions of dollars. Like it all comes down to money, and the two in America, there were 3 weeks from being decommissioned.
I got you.
And then all of a sudden, and they have had false alerts before. So, but as soon as they've made these detections, now they have all the funding that they'll need to be open forever.
I got that. But I'm asking though, wouldn't people be saying, "Hey, you can't"? Wouldn't I be able to find lots of articles that say, "Hey, this is impossible, guys. I know these guys want, they said they did it, but I'm telling you, it's impossible to have happened." I'd be seeing that from at least some significant contingent among physicists, right?
Yeah, and I'll get it. I'm finding it right now. I'll get it for you.
What was the nature of the conversation? I mean, I
he doesn't know. He's going to find what it does happen.
Let me finish what I'm saying anyway. What was the nature of the conversation? Because the conversation could very well have been, "Hey, look at 10:02. Did you see something interesting happen there?"
Well, they're not supposed to do that.
I don't know. When you start passing the information out to the general population, it goes out to them anyway. So then they start discussing, well, what did you see? Oh, okay, yeah, we weren't looking for that.
Gone off track a little bit, Alien. I mean, you were talking about what is science, and is looking at something science, and we still haven't established as how if looking at something is science.
Well, we were talking about the scientific method, and the scientific method being something that's repeatable, retestable, repeatable, and you'd have to recreate the effect of two black holes merging with each other a billion miles away in order to determine whether or not the signal that you got matches with that. Because how do we know what the gravity, what kind of gravity wave is produced by two black holes that merge a billion light years away if we don't have something to measure that against?
Why you say it happened more than once?
How do you know that?
They make one observation.
So
Why? They publish
multiple
every time they find something. They publish.
Looking at multiple lunar eclipses is science.
I think that's different, though. I think gravity waves are hypothetical they were hypothetical until they were somehow proven to exist with equipment that's not supposed to work inside of an existing gravity field. So,
Well,
I mean,
someone pointed out though that everything's inside of a gravity field. So how does that make sense?
Exactly. Exactly.
Well, so then clearly what you're saying has to be wrong, then, right?
I mean, look at here, let me find it for you. Like there are scientists who say that this is not possible. That you can't detect a gravity.
Go ahead,
You can't detect a gravity wave from inside of an existing gravity field.
Yeah, let's say that. Like I'm looking at 2020 articles. Scientists are detecting more and more gravitational waves every day.
Right. And what do they have to measure that, or what do they have to compare that with?
Well, presumably other gravitational waves, right?
Right. Yeah. Right.
What do you mean, right?
I don't know. I don't know why it's so unbelievable, but
I find it very strange that the claim is that they're not allowed to talk to each other because the very nature of LIGO is a process of talking to each other because it's confirmed by the other units.
But we're getting away from Alien.
Have you seen
Try to remember what you said. You were like looking at a book on Mars is science, and now trying to figure out is observations just looking at something. You can think about something.
The very nature of LIGO is to communicate with the other LIGOs. I don't understand how they're not supposed to communicate.
No, but not before a detection is made. Have you seen that? Have you seen the report that the machine prints out whenever that shows the signal that they detected? I mean, literally, it looks like it was made on like Microsoft Paint. It's not a very in-depth or detailed document at all. Like I could recreate that document on Paintbrush, and if I could do that to get $1 billion in funding, just by talking to another one and having them print out the same piece of paper that says the same thing, and presenting it as something that happened, simultaneously, and I get $1 billion in funding for that, I'll do that. I mean, that's just and it wouldn't be hard. And it wouldn't be hard.
You can't believe that's all it takes. You cannot believe that that's the only analysis that's done on this data.
Dude, I mean, look at
show us. Well, show us that that's true. Because just because you saw something that you think looks like a mistake doesn't tell us that's the whole of the data that was analyzed, right? It could be that there's 1,000 pages of that.
I mean, but this was years ago, and do you think that they're going to let that information just kind of be out in the?
But if we don't have that information, there's no reason to think that you're right.
It's out there somewhere. It's just I've got to find it again.
Because
if you did something like that, would you want the papers and all the information to still just be out there where everybody could find it?
If it was out there, you'd think that people would have grabbed it and kept it. Like you saw it before. Why did you not keep it?
Some people have, and I'm going to find it. You'll see.
Okay.
The other interesting thing is that this has been proven or has really good evidence because they've used it to predict where events have happened. They've used it to identify where to point the telescopes to go and look at an event.
And telescopes to see an event? Like, what do you mean? You think they're going to see two holes merging with each other 1 billion light years away?
No, there was something interesting over here that blew up.
Why are you so incredulous that this can happen, Alien? Like, what is your background?
Well, hold on a second. We're getting a lot of background noise, coughing, banging.
That was Zant, I think. I've muted him for the time being.
So, Alien, what's your background in this that you're so incredulous that it happens? Like, do you normally read LIGO data? Like, are you?
I paid close attention to the work as it was happening. So
that doesn't mean anything.
Okay, I'm sorry.
Everyone can have a hobby of looking at this.
You're right.
Like if I look at the weather patterns for the U.S. and I look at a pretty map of the United States and they're all red, blue, gray, and I can go like, oh well, anyone can fucking print that out. Let me go make a bunch of those so I can get a bunch of money. I mean, that's not how it works. The graphs you're looking at correspond to actual data that they've collected. So just saying, oh, well, I could have made that graph doesn't mean jack squat, because guess what? You don't have a LIGO in your backyard that people.
You got out.
How'd you get that?
Yeah, you know what a gravity wave is, right?
I've read about it. Yeah.
Right. They propagate through the universe from 1 billion miles away. It's a wave of gravity that propagates through existing gravity waves or gravity fields, and they get distorted. It gets distorted by existing gravity fields, right? So it's happening 1 billion miles away. You know how many gravity fields there are between
Actually, I don't know.
the Earth and something that's 1 billion miles away? A lot. You know how much distortion? You know how much distortion that is?
Really big waves. That's why we can't detect small events. We can only detect huge events. And what I found interesting, because I remember the article that you posted from 2018, and that's interesting. But haven't you noticed all the other articles in the New Scientist since then? Because in 2018 we kind of got some indicators. Then in 2019 we actually got some really good results. 2020 even better. 2021 even better than that.
How do you know that?
Through the same articles that you're referencing to cause doubt.
How do you know that those machines are detecting gravity
No,
waves?
no. I'm just using the same source for articles that you bought to cast shade on LIGO to also say that's not representative of the views of New Scientists. And it's not representative of the most modern understanding. Because like most things, as we get more data, we increase in confidence. Have I examined that data personally? No, I haven't. But that's not why I think the Earth's a globe. So what?
Not a flat earther, he's a globe.
To the point that you were making about how can you detect them? I mean, you've been out overlooking a pond before, and when it rains, you notice there's a bunch of little tiny ripples. But if you drop a big fucking boulder in there, that ripple, even though there's a bunch of other little ripples going along, that big ripple can still travel through the others and reach you at the shoreline. It's no different.
And again, why are you posting an article from 2013 rather than something that's up to date after you've actually discovered them and we've got firm data to support it? You're pointing everything that's old.
No, it's because one of the details that we should have these gravity waves propagating the entire. We should have them all over the place, propagating the entire universe.
And then you look at the scale and the sensitivity, and then you understand why we pick up what we do, because the only events that we're picking up are huge events.
How the fuck do you know that they're gravity waves, though, dude? That you have nothing to compare it to.
I accept what the scientists are telling me from that perspective, and all I'm saying is, according to what they've said, what you're saying is not the case.
So why do they say that they know they're gravity waves? What is the standard answer to that? The mainstream answer?
Because they make billions of dollars in
No,
funding.
that's not their answer. That's not their answer, Alien. Come on.
Yeah, that's not their answer, but yeah, sure.
Yeah, I'm asking you, what is their standard answer? What's the answer they will present for why they know that they're gravity waves?
Because two lasers that are synchronized become out of phase by the width of the length of a proton. Such a small value that it's fucking incomprehensible.
But Alien, I'm asking you though something specific, because I'm asking you. So if you say to them, if they were asking me for $1 billion, and I was like, I want to give it to you guys, but one thing before I do, how is it that you know these things you're detecting are actually gravitational waves and not just something else, some other phenomenon? Do you know what they would say to me? Because they wouldn't say what you just said. They wouldn't say, well, it's just because we want $1 billion. No, they wouldn't.
Yes, they would. Yes, they would.
Explain to me how that means that they're gravity waves.
Exactly.
That's my point. That's not their whole answer.
That's my point. Yes, it is their answer.
Oh, come on, don't be naive,
dude. I'm not kidding with you. Not
Okay,
cumulative.
I'll
They
look it
say
up. I'll
that-
look it up.
They say that the universe stretches a little bit, and that's
Yes, I
what
know.
causes. And that's what causes these lasers to become out of phase. But that's not the only thing that could cause those lasers to become out of phase. Somebody's
But if they
stalling
don't
their
have
car in the parking lot.
Yes, but your
to create
claim here,
enough
your claim
noise.
here, yes, your claim here is the car starting that they have to account for every single contribution that could possibly happen, and they don't do this, and that they won't have any answer to that question. That's your claim,
And
right?
by the way, there's only one laser.
No,
the beam is
two.
split.
There's two
The
lasers.
beam is split. The beam is split. In the LIGO paper, they say there is one laser. The beam is split, sent in two different directions.
Yeah, but then they're still compared with each other. The phases compared with each other to see if if they're still in synchronicity with each other. If they're off by the length of a proton, then there's two different measurements that they take. So I mean, essentially, there's two different lasers.
No, it's from one laser.
Yeah, but dude, never mind.
But isn't it true though? If two
they have
places
to
detect
compare.
it, go ahead.
They had to compare the laser going one direction and going another direction. It's basically two lasers. Why else would they split the laser? They have to have something to
Because they
compare.
need two directions. That's why.
Exactly. So
Yeah,
essentially
one
they have
laser.
two. Have you ever seen
Unlike
seen the LIGO antenna? Have you seen the LIGO
Yeah.
antenna before?
One light source.
One goes one direction, the other one goes the other direction. They're splitting the laser into two lasers.
Is the laser the actual mechanical instrument, or are you saying the laser is the light itself?
No, it's an actual laser. It's an actual wavelength.
I mean, so your problem is the incredulity of the sensitivity of the measurement, yeah?
Well, what's a reasonable amount of sensitivity?
I'd like to address that point first.
I mean,
before we
I'd
move
like
on,
I'd like
if
to
there's
know
anyone
how. I'd like to know. I'm still trying to figure out how they measure the length of how they measure these two wavelengths. How the difference in the length of a proton.
You'd have to look into the science.
If you want to know things, then say that, not just it doesn't make sense.
Well, that's a much better position for us to approach it from. How do they do that? I don't know. Is the simple answer. That's
Yeah,
why
so
I
the
thought
way-
it was a reasonable question.
Yeah, the way they do it,
Yeah, I don't
and
know
the
either.
reason why they split the beam is that what that does is that you'll get two lasers or two directional lasers that will be in the exact same phase length, and then when they come back and meet up, they recombine, and what you'll get as a result is a varying amount of light. And and what I mean by varying amount is that when one of them gets shifted, one of the wavelengths, the phase lengths get shifted by a tiny bit, the resulting strength of the light that you receive will be slightly different because the peaks and the valleys of those waves have been mismatched. So you're not really measuring a length, you're measuring a strength of the laser. That's how you're measuring that small length because you're using it. Yeah.
But by the width of a proton, though.
Right. Well, what do you think is
Yeah,
a reasonable
because-
amount? What do you think is a reasonable amount for them to be able to measure, and why do you limit it to that?
The thing is, they're not necessarily measuring the length, they're measuring a change in the light, a change in the intensity of the light, and then that equates to a phase length shift of the length of a proton. So yeah, sure, you can say that it's inconceivable to measure that length, but you're not measuring a length, you're measuring the effect that phase length shift has.
So this is going to be a time measurement issue, then, isn't it? It's almost like time delay reflectometry, kind of. But we're seeing how when we get that result back, how those waves mesh up to each other, and if there's any incongruence between those wave peaks and troughs. I'm guessing to put it in simplistic me kind of line.
Yeah, like in the most simplistic way, if one of the directional lasers have been shifted, and there's a reason why they're 90 degrees to each other, because that is how you've kind of figure out that it is gravitational waves. Is that you get this phase shift between the two, and then you don't measure lengths, you measure a difference in light strength, in light intensity, and that's how you can actually go from having to measure a super small length to instead measuring a change in light intensity, which is easier to do than measuring a small length.
Can I talk yet, Jen?
Yeah.
And then just one more thing to when you say that other things can cause this. Well, the main thing is, sure, local thingies can cause this and all of these things, but there's a reason why there's 2 buildings on different places on Earth that have the
4.
exact same kind of disturbance in the lengths of the phase shifts. And they had it at the same time and in the same exact manner. And the only way to explain this is for some sort of global event making this happen in the same way, which the only current known way that could ever happen is with gravitational waves. Sure, you can try and speculate that there's another way of doing this, but I would love to hear what kind of way you propose that 2 different locations of Earth have this same exact problem happen, or not problem, but
there's 8
deviation.
people. But there's 8 people on the face of this planet that we have to trust that all that stuff happened exactly the way it did.
Well, that's not entirely true, though. It's because, for example, I've just been reading a lot about this. So I'm catching up, and so all the complaints that you've been making were made as soon as the gravity wave was detected. People came out of the woodwork and started making these criticisms, right? And in 2018, 2 different independent bodies of collections of experts, of physicists, went back to the data and began to test these claims. I guess there was a very, very prominent physicist who said that he found correlations in the data that imply that maybe they didn't detect gravity waves. So these 2 teams went and they spent a year at reanalyzing all the data, and I guess I haven't read the paper yet, but they published a series of papers for which the conclusion they came to was these results are absolutely rock solid. The criticisms we just spent a year analyzing are not valid. I don't know why exactly, because I haven't read this article yet. It's quite thick, but I'm going to post all the stuff I'm finding. But so evidently, I think the story that I'm telling you is that there are reasonable people in the mainstream who have taken your concerns, took them seriously, formed teams to evaluate them, spent a year doing so, and decided they weren't correct.
A year to enter to observe a little graph made in PowerPoint. Jeez.
Yeah.
Well, I'm looking at sort of atomic clock accuracy, and that's now down to sort of, a thousandth of a nanosecond or 10,000th of a nanosecond are in achievable intervals.
Well, that's where my question came in. Your incredulity about they can't measure this is bizarre to me. I mean, I don't know what they can measure, but I don't have any information to suggest that they couldn't measure.
You don't have to prove a negative. You have to prove that they could do it, and try and find some information about the equipment that they use to measure the wavelength, the wavelength synchronicity.
But
the thing is, it can be very it can be very like to say, oh, it's really like, how would you ever measure the length of a proton? Sure, that can be very like your question, but when you find out that they're not measuring the length of a proton, they're measuring the light intensity that happens due to the phase shift being the length of a proton, and so that now the difference is you're measuring a light intensity, and then can you figure out how much would that be? Like, could we measure that? And yeah, we can. That's why we've done it. But if you want to look into more of that, then yeah, that's fair. But so far, that argument is just, I don't see how they could do this. Well, this is how they did.
I remember I had this same argument years and years ago with just the speed of light when I was 10 years old. Like, how the hell do they measure the speed of light? And then I found out it's quite easy. But initially, it's like, how do you measure something that's moving 186,000 miles per second? Wow. I mean, my incredulity level was off the chart.
What wavelength they are using?
LIGO?
Yeah.
That's some insider baseball, man. I don't know.
Hey, Alien, is the things I'm posting, have you seen these things before? Were you aware of these today?
Not paying attention. What?
I was asking you if have you seen the stuff I'm posting with these new studies that were quote unquote rescuing the gravity wave data out of the noise? Have you seen these studies before?
I've seen some of them. Yeah.
Okay. I'm finding them quite compelling myself, but I don't know if you will or not.
So if you had a wave in a tube, and then that wave hits the mirror, if the mirror wasn't at a precise angle, it would deflect the beam off in a skew direction, right? Like the LIGO setup would have to be built to exact precision. Like you guys were talking about photons, right?
Yep.
They multiply the effect by doing multiple paths.
By photons, do you mean discrete packets of energy?
Yes, it has to be very precise, though. You're right about that.
Yeah. We're talking about smaller than millimeters, right?
Yes, it's much smaller.
Absolutely
Much smaller.
Well, they don't first off measure the angle of the mirror. They measure the length of the tube, and the length of the tube appears to change in length. That's what the ideal measurement is to do that. And what they do is they also, in order to multiply the effect, they send it up and down. I think I have a number in my head of 196 miles. So they're making a shitload of passes back and forth in order to multiply the length of the tube.
So Earth tremors don't affect it.
No, they do.
Yeah, they do.
The Earth's gravity right next to it don't affect it.
Oh, it does.
The Moon's gravity,
Everything affects it.
238,000 miles away,
Everything affects
don't
it, dude.
affect it. The
Everything
Sun's
affects it.
gravity, 93 million miles away, don't affect it. But a
Everything
signal
affects it.
from a trillion miles away affects it.
Everything
more than a
affects
trillion. He's more than a trillion.
You didn't hear anyone say.
You are just offering incredulity here. I think
The next
Alien
closest.
said, he said he doesn't have to prove a negative, but I think if you want your argument to be compelling, I think you need to offer more reasons
Maybe
why this
falsify it.
can't happen than just you think it's incredible.
Oh, and just so you know, the next closest star to us is 30 trillion miles away. So
We know.
just
30 trillion.
Big numbers. Big numbers just can't be true. There
They
can
can't
be no big numbers.
Or small numbers. Small
I'll tell
numbers.
you what, if you
Yeah.
take that number and multiply it by just over 5,000, you get that distance in feet, and that would be an even
30 trillion
number.
miles.
Yeah,
I
it's
think
even
that's
a bigger number.
75,000 years for the light to get.
Come on. Yes, we know. We know.
How many
Have it.
millimeters? How many millimeters is it to the nearest star?
a lot. It's a lot of millimeters.
You
Well,
got
how many nanometers? Go ahead.
I mean,
even more.
What big
even more
numbers are allowed? What's the biggest number that isn't incredible?
5'6".
There's no such thing as an incredible number. They're all feasible.
Yeah, they're all
and
big.
people's incredulity about these things is absurd. Although, to be fair, Alien is, I think, safely more sophisticated than just it's a small number. I think he is.
So when have you verified these huge astronomical numbers?
Exactly.
You don't have to, mate.
He's doubting that things are light years away. Is what he's doubting. Is that what you're doubting too now?
And it's no offense to anybody in the room. It's just for years,
When have you verified the ingredient in Coke?
Hang on,
mean,
I've actually Sharky though.
Yeah, he's a
I have
flat
looked
earther.
at the ingredients
I thought
and stuff like that.
I thought this was a flat Earth server.
It's a
I'm
recipe
surprised that there's not more people that are
Well, Merle is talking.
that are
Merle is
that I
talking right
think
now
the
is
Earth
a flat earther.
Yeah, I don't think that the Earth is flat, but I mean, you would think that the people who do think that the Earth was flat would be on board with this idea that fucking gravity.
We don't think most people in here talking to you right now are not. Most people talking to you right now are not flat earthers. But fortunately for you, the one that was just talking when you started talking is a flat earther. He's about to tell you that space doesn't exist and that planets are not really as far away as we say. Go ahead, Merle.
Yeah, and flat earthers don't think gravity is even a thing.
And there's
Go
no
ahead, Merle.
gravity at all, so
Guys,
obviously
Merle,
no
let's go,
gravity
let's go, Merle.
The LIGO measurement.
I think Sonic's ready to flip flop. I think Curve's ready to flip flop.
Guys, it's Merle.
Unbelievable.
I think Gem's
I don't think
already
anybody
a flat
listens to
earther.
anything that's being said. They all just sit there thinking about what they are going to say.
It's so obnoxious. Merle, it's your turn.
Go ahead, Mel.
Thank you. It's just a chime, just for on the incredulity level, that many of us, myself included, were being spoon-fed this astronomical concept, and for most of my life, I took it as a given. That's what was happening, you know. And then not that long ago, I just started to really scratch my head about it. So that's what's really happening here. I think just as a outsider, even you don't have to claim flat Earth or globe, and I'm nearly there, 10 seconds. It really is just another reassessment of what we've actually been told, rather than just taking it on like there's experts, they've figured all this stuff out, and I've just got to trust that. You know what I'm saying?
Don't have to. You can go and learn them science and do it yourself.
They don't just say, "Oh, this is what we got. Trust us." They tell you how did they do it, with what building, with what specifications, what did they do, what wavelengths lie, like what kind of measurement, where the two different interferometers were. They told you that, like, they give you the data of what they measured, and like you can technically, if you had the money, you could do all of this on your own and confirm that what they're doing is correct. Like, they're not just saying believe us blindly. That's not what they're doing in the slightest.
Well, they kind of are.
No, they're only if you're at the standpoint that you don't want to learn anything or try and check anything. Sure, they are, but they give you all the necessary information to check if they're doing it correctly or not.
I appreciate that, Gummy, but again, and I'll try to get this out as quickly as possible. This isn't about anti-learning or not being able to take on new information. And to Jem, this isn't about a fear of big numbers. I actually, at this stage of my life, have no idea how big wherever we are is, or what we're surrounded by. I have no idea, Jem.
Well, you can't have an idea, can you? According to you.
It's
not possible. You need personal verification of everything. That was your opener, wasn't it? Yeah. How have you verified these distances? So if you think the methods that we currently have are no good, then you're stuck with that position. You can't be anything else, and that really is my problem with flat Earth. It's a route to ignorance.
Because I'm not saying that the methods are wrong. I think it's just, for a lot of us, it's a leap of faith, because I think everybody's honest enough in this room to acknowledge we don't know if the universe is infinite. None of us have verified that. Neither of these fucking stuffy old cunts at the top.
I don't think the universe is claimed to be infinite. Who cares? It's irrelevant.
It's so big.
I think
how can you get your head around that?
When you've travelled a fair amount, when you've done distances personally, I think you've got a reasonably good concept of how far things are away from each other to some extent. I mean, all I can say is with my experience, I've ranged stuff up to about sort of 35,000 kilometers away, and I've done that personally, and that's not been stuff on the surface of the Earth. So beyond that, you're right. Tangible, personal. I can't rely on any other knowledge. That's as far as I go. But so what? Doesn't have anything to do with the fact that the Earth is a globe and we observe it to be such.
Well, if I can just make the full stop, like, I'm not denying space either. Like, I need to address this at some stage. Like, I never really did. I wasn't one of those people who said space is fake or a hologram. There's definitely a space above us. Whether it fully encapsulates us and goes all the way around and we're inside what they call a universe, that for me is still on the table. But I just want to get that clear. I'm not denying space.
Do you think it's somewhere we could go, though?
No, I think there's limitations. I'm not clear on all the reasons why, but I think there's definite limitations.
Do you think we can go to the bottom of the ocean, Brian?
No, we can't, can we? Absolutely.
So do you think that's all been fake too then?
What
And
would
keep
inhibit
in
us from going to the bottom of the ocean?
And keep in mind, the dimensions of the planet and the ability to measure our planet is far, far simpler than what's going on in this argument about Lagos. I mean, we're dealing with shape and dimension of something that's tangible. I mean, the South Pole exists, so shape is done.
The shape
South
is
Pole
done.
exists. What, the ceremonial South Pole?
The shape. The shape is far from done, guys. Like you can put the whole Earth in cross section map format. You're fucked.
What does that matter? That hardly matters. No, I'm sorry, bro. That's not how it works.
Well, it does, and there's plenty of people who've done this, and it's obvious that it's not a globe.
Yeah, but that doesn't actually make the argument that you want to make, though. That doesn't get the conclusion.
But it perfectly demonstrates visually what's happening.
I know, but it doesn't show that it's not a globe.
They're called basins.
The North
They're
Pole
actually
basins.
The
Do you
North
understand that
Pole's
this doesn't in any way argue about the shape of the planet? You can put a grid over anything.
Yeah, but you can also cross-section map style. Once you visually represent the Earth like that, it makes quick sense.
But you can visually represent the Earth like that. Whenever you have a flat map, we can do that. It's distorted. It's not representative of reality exactly, but we can do that all the time. It's just an easy way to have maps, right?
It's like the North America.
I think it's very
much
practical.
fit into the Sahara in North Africa.
But the key here though is that it can be very useful for certain, like, for like say figuring out the distance to the next city. But that doesn't mean that what you have there is the accurate representation of the actual physical place.
Pretty accurate.
Well, but you've seen like the differences. You've seen the differences between, like, say, the sizes of things as they look on an AE map or on a flat map versus how they look on an actual globe. Yeah. So you see the distortions are there.
The globe doesn't have those distortions.
As big as you think.
And the globe doesn't have those distortions.
I just think it's silly to think that there's this invisible force like making water.
Yeah.
Do what they say it can do. It's just.
But we see the behavior of it every day, so that's why we think it's there. Because if it wasn't there, then what would be causing all this acceleration downward that we see? Because we see the acceleration, we see what's there.
If you deny gravity, it doesn't change the shape.
Well, but I mean, look, you just can't because we have all this stuff going. Some force is causing this downward acceleration. Though.
Yes, but that has nothing to do
with
it.
And so we just gave it a name, is all.
Yeah, no, for some reason he wants to deny shape based on the fact that he wants to deny gravity. It's irrelevant. The shape is independent of it.
I don't want to deny gravity. I'm not one of these people that was walking around in denial. That wasn't where I was at. I was a believer.
Then accept the fact that you don't need gravity to prove that the Earth is a globe. You're just trying to do that to add into your incredulity somewhere because you want to say that water wouldn't stick to it. It should fall off. Well, where would it fall to? Why would it fall off of the Earth?
Well, gravity is used to make Earth into a ball. So we need to see if gravity is all that it's cracked up to be at all.
If we never discovered gravity, we still could know the Earth was a globe.
I don't know how you can reach that conclusion, Moyle. If you take gravity out of the equation, the Earth equation, that is, you're not going to...
You have unanswered questions.
It's actually...
But you still have a shape. It's like, I don't know where a ball was manufactured. That ping pong ball that I just purchased, I don't know where it was manufactured, yet it's still a ping pong ball. I don't know what it's made of, yet it's still a ping pong ball.
The globe makes additional cosmological claims by saying that there's this globe-making force called gravity. That is the force by which everything in the universe works. Sure. That's an additional claim.
Sure, that's independent of the shape.
Well, I wouldn't say it's the force that everything in the universe works.
If gravity is making it into a ball.
Force that allows us to describe certain actions in the universe, but there are a lot of other forces out there.
Moyak, you're not making sense. If gravity's making it a ball, how's that independent of shape? That doesn't make sense. Could you explain yourself a little bit more, please?
The fact that it is a ball, like I said, with a ping pong ball, I don't know what it's made of, yet it's still a ping pong ball.
If it's irrespective of the shape of we're trying to figure out the shape, Moyak, then why are we talking about gravity?
Because you guys need it to deny here.
Moyak, you're not making sense. I can't follow you anywhere in this discussion because you're not helping us make a conclusion. You're saying gravity doesn't matter, yet gravity is constantly invoked as the reason why it's a ball. That doesn't make sense.
Well, technically speaking, we can invoke density disequilibrium, which would drag everything into a ball. Because what we see on the Earth is there is more dense stuff with less dense stuff generally above it, is how the rule generally works. So great, we'll use density disequilibrium. There we go. Now we've got a ball.
Well,
next.
If we have a surrounding medium, it would push gravity is the center.
Lemon, just to get a gauge on the room, does everybody agree with Moyak in the room, or
what do you say exactly?
Moyak was sort of saying, like, go again, Moyak. See how you go.
What I'm saying is that regardless of whether gravity exists, it's still a ball. We observe a ball. And whether it's some, we can also probably agree that there's probably something that causes the ball, but we don't have to know what that is in order for us to determine that it is, in fact, a ball.
Yeah. He's saying, look, you have ways of looking at that it's a ball that are just empirical, like observational, and the fact that gravity is why we think it became a ball. Well, it still looks like a ball. You can just look at it and see it's a ball. So he's saying that's how they're independent of each other. Because yes, we do say a constant, but
they're independent because we can on one hand measure it being a ball without using gravity whatsoever. We can also do things about with gravity and stuff without even caring about Earth being a ball. And yet, even though we can measure both independently, they do have a causation effect where if gravity is a thing, then it would make sense for it to make Earth into a ball. But they're still independent in the sense that we can measure them independently.
And Mel, to actually